Let's take a look at this example. This time, okay, we have given voltage source, we have given fuse, okay, which is made for 0.5 amps, so it means 500 milliamps is the largest current which can flow by this fuse. And we have R2 given, and we have variable resistor, okay, variable resistor, which has to be adjusted to the value, okay, which is the basically the value which is going to make the system not burning the fuse. Okay, so how are we supposed to approach this problem? First of all, you have to realize that the maximum current which can go through this circuit is 0.5 amps, which is 500 milliamps. Okay, so what I would do, I will calculate first R total. Okay, please keep in mind that I total max, I total is equal 500 milliamps, which is simply equal to 0.5 amps. So if R total is equal voltage source over I total. V1 is equal 10 volts over 500 milliamps. Okay, so this is equal 20 ohms. Okay, if you want to do this on the calculator, this is 10 divided by 500 exponent 3 negative. This is equal 20. Next, we have to realize that we have two resistors. Okay, we have two resistors that are in parallel. That's why I'm going to use the formula for the parallel circuit for two resistors, which is called product over the sum. So if R total is equal, I'm going to call this R1 times R2 over R1 plus R2. Please notice that R2 is given, R total we just found, and we have to solve this formula for R1. So in order to do so, I have to eliminate the fraction. How I eliminate this fraction? I'm going to simply multiply both sides of my equation by the denominator. So I have R total, is equal R1 times R2 over R1 plus R2, multiplied by the denominator R1 plus R2, and we have R1 plus R2. This and this will cancel out, so I have R1 plus R2 times R total is equal R1 times R2. Next, I'm supposed to distribute R total into the parentheses. So I have R1 times R total plus R2 times R total is equal R1 times R2. Okay, so we have to find value of R1. So all terms which contain R1 I'm going to move to the right side, and everything without R1 I'm going to keep on the left side. So I'm going to move this one over here. Alright, so I have R2 times RT is equal R1 R2 minus R1 R total. Please realize that in these two terms we have common factor. Common factor for these two terms is R1, and I'm looking for R1. So I simply write R2 RT is equal, factorize R1, so I have R1, and I have R2 minus RT. Okay, in order to find R1, I have to divide both sides of my formula by the content of the parentheses. So I have R2 minus RT, and I have R2 minus RT. So this and this will cancel out, and I have R1 is equal R2 times RT over R2 minus RT. This is equal. R2 has the value of 220 ohms, okay, and R total is equal 20 ohms, so I have 220 ohms times 20 ohms over 220 ohms minus 20 ohms. This is equal, now we have 220 times 20 divided by open parenthesis. I have 220 minus 20 close parenthesis. This is equal 22 ohms. I have 22 ohms. So we found the value of the resistance R1. Now we're supposed to verify if this value is correct. So what I'm going to do right now, I'm going to find each current, okay, each current in this circuit. I'm going to find IR1, I'm going to find IR2, and I'm going to find I total. So we have to keep in mind that this is the parallel circuit. In parallel circuit, voltage source is equal to VR1, and this is also equal to VR2, and this is equal 10 volts. Okay, in parallel circuit the voltages are the same. Next I'm supposed to find IR1, which is equal VR1 over R1, which is equal 10 volts over 10 volts over R1, which is equal 22 ohms. Okay, so you can use the calculator if you want to. 10 divided by 22, this is equal 454.54 milliamps. So this is 454.54 milliamps. Okay, so this is the current which will flow through the resistor R1. And now I'm supposed to find IR2. IR2 is equal VR2 over R2, which is equal 10 volts over 220 ohms. So now I'm going to use the calculator, and I have 10 divided by 220. This is equal 45.45 milliamps. This is equal 45.45 milliamps. Okay, please notice that the resistance R1 has much lower resistance than resistor R2. Okay, so the higher current is going to go through resistor R1, and the lower current is going to go through the higher resistance, which is resistor R2. Okay, so keep in mind that the current is very lazy guy and is always looking for the lowest resistance to go in order to reach the ground. Now I'm going to find I total. In order to find I total, I'm going to use KCL. I total, this is equal IR1 plus IR2. So this is equal 454.54 milliamps plus 45.45 milliamps. Okay, this is equal, I have 454.54 exponent 3 negative plus 45.45 exponent 3 negative. This is equal 499.99 milliamps, which is approximately 500 milliamps. 500 milliamps is equal 0.5 amps. So please notice what we got over here. We have fuse, okay, for 0.5 amps. So it means that the lowest resistance which can be applied over here, okay, the lowest resistance which can be adjusted on variable resistance is simply 22 ohms, and this is the solution to my problem.